The first practical experiment we're going to do is mixing hydrochloric acid and sodium hydroxide. So we start with 5 ml of sodium hydroxide in a test tube. We take the temperature and then we add our hydrochloric acid and record the temperature again. Okay, Chris, what's the temperature of the sodium hydroxide, please?
The temperature is 23 degrees.
23 degrees. Could you now add 5 ml of hydrochloric acid to your sodium hydroxide?
This one?
That's one. And we use 23 degrees. And if it's an exothermic reaction, the temperature will go up. If it's an endothermic reaction, the temperature will go down. Okay. Now just give it a twirl with the thermometer to let those chemicals mix. And see if we can notice any change. What's the temperature now, Chris?
The temperature is now risen to about 25 degrees.
Okay, that shows a rise in temperature. Is the reaction an exothermic reaction or an endothermic reaction?
Endothermic.
It's an exothermic reaction when the temperature rises. So there's been a release of heat. Good. This experiment is adding sulfuric acid to water. What's the temperature of 10 ml of water, Chris?
The temperature is 21 degrees at this stage.
21 degrees. Now we're going to add 5 drops of concentrated sulfuric acid and then record the temperature. Skyrocketed right up to 35 degrees. So we've gone from 21 to 35 in a very short amount of time. Is that an exothermic or an endothermic reaction?
This one's an exothermic.
Yep,
definitely.
Exothermic reaction. And if you feel the temperature, you'll notice that it's quite warm. You won't be able to feel it through the gloves match. But so water and sulfuric acid releases heat and is an exothermic reaction. Okay, the third experiment, we've got 10 ml of water. What's the temperature of the water?
22 degrees at the moment. 22
degrees, and we're going to add 1 gram of potassium nitrate. So just over 1 gram goes into the 10 ml of water, and we'll see if we've got a exothermic reaction if the temperature rises or an endothermic reaction if the temperature falls. What's happening this time, Chris?
We've got an endothermic reaction this time.
How do you know?
It's started at 22 degrees and it's currently 18 degrees and still falling.
Okay, so it's dropped by 3 degrees and still going. Very good. We've got an endothermic reaction when we mix water and potassium nitrate. Okay, Chris, our next reaction is mixing 10 ml of water with 1.5 grams of anhydrous copper sulfate. So you're measuring out the copper sulfate.
Yep.
And we're going to add that to the water. Okay, we've mixed water and the copper sulfate, and the temperature has gone from 21 and it's slowly rising. We've got 24 degrees at the moment. Next experiment is adding magnesium to 1 mole of copper sulfate. So we've got 5 ml of copper sulfate and we're going to add 1 gram of magnesium filings. At the moment our temperature is 22 degrees and Chris is now adding the magnesium filings. Temperature is rising from 23. We've got quite a vigorous reaction, a lot of heat and gases are being produced. The temperature's going up to nearly 30 degrees. So is that an exothermic or an endothermic reaction? So the copper sulfate and magnesium filings produces a strong exothermic reaction. The temperature's gone above 50. We had to change thermometers and it's up to 65 and still rising. And the colour has changed. We've got bubbles being formed and we're up to about 70 degrees and still climbing. I think we're stabilising at 73 degrees. So strong exothermic reaction with copper sulfate and magnesium filings. This is the last of the 6 mini experiments. We've got 10 mils of water at 20 degrees and we've got
1.5 grams of sodium thiosulfate.
So 1.5 grams sodium thiosulfate, and we're mixing the two together to see whether the temperature rises for an exothermic reaction or the temperature falls for an endothermic reaction. This time the temperature has fallen from 21 degrees to about 16 degrees. What does that tell us, Chris?
This is an endothermic.
Very good.
It goes down.
So this reaction requires energy. It's endothermic.